Good afternoon, Farmington High School. This is the third time I've made this video today, so we are going to talk extra fast so I can go home tonight. So thank you. This is Unit 6, Notes 2, Exponential Functions. Learning target, I can graph and interpret exponential functions. Now, here's the deal. We've had some awesome functions, so I'll show you some examples. So here, we have what we used to call y equals mx plus b. So these were our slope, or our linear equations, and linear has the word line right in it, and that's what they were. They would make a line. Then we had the last unit, Unit 5, bx plus c. These were our quadratic, and these were parabolas. So we had them with maximums, we've had them with minimums. Okay. And now we're going to have exponential functions. One thing you might want to notice, this is to the second power up here. Second power up here. This was the first power. Now, the variable is in the exponent. So a is going to be a term, like a constant, and it's going to be a coefficient. A has to be the coefficient greater than 0, and it cannot be 1. If it is less than 1, it is going to get smaller or decay. And if it is greater than 1, alright, it is going to increase. Alright, just something to think about as we talk about exponential functions and exponential growth and exponential decay functions later on in life. So linear were line, they had a power of 1. X squareds were quadratics. Now we're going to have exponential functions, and really exponential functions are either going to grow or they're going to get smaller and go close to 0 but never actually touch. So let's look at these. Y equals 4x. One thing we're going to do is we're always going to start with negative 1. Alright, so 0 is always our y-intercept, and then we usually just do a value here. That's negative 1, just to see kind of where the graph came from. So we know when it hits 0, what direction it's going to kind of take off towards. So 4 over 1, we know if an exponent is negative, that means it wants to be positive, and we move it down here to the bottom. So now it's a positive 1, which is really just 1/4, because 4 to the power of 1 is itself. Then we'd have 4 to the 0. Anything to the 0 power, remember, is 1. 4 to the first, we just talked about it, that's itself, so it's 4. 4 squared equals 16. And 4 to the third equals 64. So you can kind of see how fast this is going to grow. The other thing you can look at is this is times 4. This, 1 times 4. 4 times 4. Times 4. So whatever this coefficient is here, whatever power it's raised to, if it's the one being raised to a power, it's going to get 4 times bigger every time. That's why it's the coefficient. So when I graph that, negative 1 to the 1/4 is down here, 0, 1. So I can tell it's going up. Well, how much is it going up? 1 to the 4th is up here. 2 to the 16th is all the way up here. I mean, 64 is off the charts. So it grows exponentially fast, all right? By 3, we're off the chart already. So you guys got to pay attention to how fast some of these things can grow. Also, y-intercept here is 0, 1, so y-intercept is 1, all right? Because it doesn't have a coefficient in front of the 4. It just has the 4 being multiplied by something. So 2 to the 3x. So you can kind of assume 3 to the negative 1 is equal to 3 over 1, which is 1/3. And you can tell that that's when x is negative 1. When x is 0, 3 to the 0 is equal to 1, because any power to the 0 is 1. 3 to the first is 3. 3 squared is 9. 3 to the third is 27. Well, how did I get 1, 2, and 3? Because we know that we are just doing negative 1, 0, 1, 2, 3. All right, these are the easiest values to plug in. That's why we're doing them. All right, so then we graph it. Negative 1, 1/3 down here again, 0, 1. 1, 3, 2, 9, 3, 27, probably up here somewhere. And you can see this graph grows pretty fast as well. All right. Now notice this y-intercept, right? The number being multiplied out front is 1, so that's why your y-intercept is 1, right? So x equals 0, y is the coefficient is 1. Now 3 to the x grows. It's not quite as fast as 4 to the x, but you can see that it goes up by a lot and increases. So let's do this a little bit differently. Let's go 4 to the second. So here's our coefficient. So 2 to the negative 1 is going to be that half again. And then we got to times it by 4 yet. That's going to be 2. 2 to the 0 is 1, times the 4 is going to be 4. 2 to the first is 2, times 4 is 8. 2 second is 4, times another 4 is 16. And 2 to the third is equal to 8, times that 4 at the beginning is 32. So then when I fill my chart in, I went negative 1, 0, 1, 2, 3 again. But I'm going to have 2, 4, 8, 16, 32. When I fill in my graph, negative 1, 2, 0, 4, 1, 8, 2, 16, 3, 32. So you can tell this one started a little bit higher, but it still grows rapidly. Now our y-intercept is 4, because that's right here. Now, when you look at this stuff, this is being multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. So that needs to trigger in your brain. Under the x, the exponent is raised. It's 2 to the exponent. Now then what you look at is where did it start at? Well, it started at 4. That's an indication that you're multiplying by 4 to start. So whatever it increases by is what the exponent is raising to the power of x. Then where you start and how it's changed is how you determine what the y-intercept is. So if the y-intercept is 1, then you're just multiplying by a coefficient of 1. If it's a 4, then you're multiplying by a 4 out front. So that's how you determine your y-intercept. Let's look at 4. Now, this one is 1/3, so I cautioned you a little bit. That one is less than 1, so we might have a smaller one. We might get smaller here. I don't know why I wrote a 5. Let's get rid of that. We're doing negative 1, 0, 1, 2, 3 like always. 1/3 to negative first is actually going to flip and be 3 over 1 times the 6 out front. 3 times 6 is 18. Then you'd have 1/3 to the 0 power. Well, let me write a 3 there. So 0 power is going to equal 1 times the 6 out front is 6. Right? Then you'd have 1/3 to the first is going to be 1/3 times 6. 6 times 1 is 6. Divided by the 3 is a 2. Right? And then this is where things get tricky. So if I have 1 squared, it's 1. If I have 3 squared, it's 9. Times the 6 would be 6/9. You divide top and bottom by 3, and you would get 2/3. Alright? And then 1/3 cubed. 1 to the third is 3. 3 cubed is 27. Times the 6. 6 over 27. You reduce by 3 again. 9 divided by 3 is 9, so it's 2 9s. So we go up. Negative 1 to the 18th up here. 0, 6 is still pretty high up here. 2, 1, 2 is here. But 2, 2/3 is going to be here. 3, 1/3. Right? You can see how fast they can decay as well. So we had them growing really fast. Now we have them decaying really fast. Came from a big number. Notice it doesn't get to 0 here. Just a fun fact for you. But you should see the y-intercept is also 6. Well, big surprise there. What's our coefficient out front? A 6. Alright? We can also see 18 divide by 3, divide by 3, divide by 3. Well, what they do, and instead of writing divide by 3, they write 1 divided by 3, or the fraction 1/3, because multiplying by a fraction is the same as dividing. So they know how to create that exponential function by looking at what's being multiplied or dividing. So then 5. Alright, so this is a new twist too. Here we have something we've been used to, but we have a +3 now. So -1, 0, 1, 2, 3, you fill out every table in the packet that way. Right? Except for 1, I think. And we'll talk about that when we get there. Now, y. Alright, so 2 to the negative first, we talked about that. It'd be 2 over 1. You need to move the 2 to the bottom to make it a positive 1, or that's 1/2. When you're adding 3 to 1/2, I would say 3.5. Alright, 2 to the 0 is equal to 1. 1 plus 3 is 4. 2 to the first is 2 plus 3 is 5. 2 squared is equal to 4. Plus the 3 is going to be 7. And then 2 cubed is 8. Plus the 3 is going to be 11. Alright, so 1 3/2 is about here. 0 4 is here. 1 5 is here. 2 7 is here. 3 11's up here. So you can see it's starting to grow a little bit. Excuse me. Now, when I look at this, right, this goes up 1/2, 0.5. This goes up 1. This goes up 2. This goes up 4. So I can assume the next one's going to be up 8. So this is going to be 419. If I look on my graph, 419 is right here. I think I knew it was coming. Right, your y-intercept, though, is 4. So I would have said, hey, we know that it's 0, 4. Okay, but the weird part about it is what's 1 times, how does 1 get to 2? Times 2. 2 to 4 times 2. 4 to 8 times 2. Right, so you are actually multiplying by 2 here. Even though there's a pattern of adding by 1, then 2, then 4, then 6, then adding by 16, you get that number by multiplying by 2. So that's how they get the 2x. So then you know that 2 to the 0 is equal to 1. Well, how to get up to 4? So if it's an adding pattern, then it's an adding function, and you just increase the 1 by 3. So that's how they get the +3 in that function. So there's a lot of different ways to teach you how to do exponential functions. You just have to understand what's going on. We're going to give you these functions, and you're just going to fill in the tables and values accordingly. So this one's going to be subtraction. We also have this half thing going on, so we're going to get smaller. So like if I add 1/2 to the -1, that's actually going to flip, become 2 over 1. Well, I got to multiply it by 2 and subtract 1, so 4 minus 1 is 3. So this would have been 3, -1, 0, 1, 2, 3. All right, 1/2 to the 0 is 1, times 2 is 2, minus 1 is 1. So y-intercept is 1. Now then you'd have 1/2 to the first is 1/2 times 2 is 1 minus 1 is going to equal 0. All right, then we'd have 1/2 squared. 1 squared is 1, 2 squared is 4. You would multiply that by 2 and minus 1. 4 times 2, or 1 times 2 is 2, which would be divided by 4 is 1/2 minus 1. All right, I get -1/2. All right, then you'd have 1/2 cubed, which would be 1 cubed is 1, 2 cubed is 8. Subtract times 2 would be 2/8, so that'd be 1/4 minus 1. I get -3/4. All right, -1/3 is here, 0, 1 is here, 1, 0 is here, 2, -1/2 is here, 3, -3/4 is here. So now it's just this little curve here. Now notice, it's under 0 already. Well, that means that to me that you have to have subtracted by at least 1 to keep it above this 1. And that's what they did there. Alright? Divide by, or subtract 2. subtract 1, subtract a half, subtract a fourth. So to me, 2 to 1 is divide by 2, so that's how they get that half. And then how would you cancel that out to get there is with that 2. So just paying attention to how things are working is a great habit to have. So then we have this movie tickets. So earnings in millions is modeled E equals 499 times 0.692 W. So I want to write that. Represents earnings in millions of dollars, and W equals 0. Well, we don't have W, so our X is actually the W. Our Y is the earnings, E. So opening weekend is 0. So this is the one I was talking about. We don't actually start with -1 because we're not having pre-sales and stuff. We want to know how much money we earned opening weekend. Well, if I put W as 0, the 6.92 is going to go away, and you're just going to have 49.9. Now, a good skill to have in your calculator is to know that you should put 4.9 times 0.692 to the first in your calculator. Because 49.9 times parentheses 0.692 close parentheses caret 1. So notice this is the caret. Alright, so I haven't talked about that much. If you didn't know how to get some of those values previously, I kind of went fast, but if you got a calculator, like 7, 8, 9's here, right, on the side here is an x squared button, and then above that is this little caret key, right? That is to raise it to the power of whatever you want. So in this first one, I want 1. So if I do that correctly, I'm positive I did. You do it correctly, you get 34.5. And then what you can do is just hit up on your calculator again, and you can change this 1 to a 2. So then I would change this 1 to a 2. And that's going to tell you what W when W is 2. And that's going to be 28, 23.9. Then you're going to hit up on it again, or type it all over again. I won't do that. I would just hit up. This is going to be about 16.5. Then if I hit up again and change it to a 4, you're going to have about 11.4. So now you need to know how to graph this. So what I did earlier is I would make this 0, 1, 2, 3, 4. They give me a graph. Let's trace it out a little bit. Now, there's about 20 there. I'm just going to go by 5, so I'm just going to go that this is 10, this is 20, this is 30, 40, 50. So up here is 50, 0. Then I go 1 to 34.5, so that's going to be just under 35. 2 is going to be about 23, so that's going to be here. 3 is going to be about 16, so we're going to level off a little bit. 11's here. So you can start to see that this function is going to level off something like this. Okay, then it says, estimate how much money the movie made the opening weekend. Well, that's done. Opening weekend's about that 49.9. Some of the other questions it might ask is, how much money the third weekend? And that would equal 16.5. That's right here. Okay? Estimate the total after 4 weekends. So it says the total, we're adding some things up. After 4 weekends, I would come down here and I would just add all these values together. And that would be the total after 4 weekends. So there's a lot of possibilities and open-ended questions that they could ask you to evaluate, right? But you need to know how to use the caret key. You need to know how to graph, find the values, know what squared and tripled and quadrupled and squared and cubed and all those terms are meaning. Alright, last one. Some people say that the value of a new car decreases as soon as it's driven off the lot. The function, 25,000. So V equals 25,000 times 0.82T. So I would have said, argued our X is now a T, our Y is now a V for vehicle value. Depreciation value of a new car that cost originally 25,000. So, graph the value of the car in T represented in time in years from the time of purchase after 5 years. So the value after 1 year is something we can calculate. The value after 0 years is going to be that 25,000. So some people won't even write 25,000. They'll just do 1, 2, 3, 4, 5, and I know it's not on there, but graph it anyways, because we want after 5 years. I'll start it there for you. That's why we're doing 5. Now 1. So what I would type in my calculator is 25,000. Holy, that's 25,000. 0.82 caret key, and I just put 0. And by 0, I know 0 is going to work out to be 25,000, so I'll start with a 1. So 25,000, parentheses, 0.82, close parentheses. To the first, I get a value of 20,500. Then I just hit up on the calculator. If you hit the up button, it re-enters things. So then you can change it to a 2, and you get 6,810. Then if you do it again, I'm literally doing it on a calculator right now because I don't know the answer. So you guys should be practicing it as well. Right? If you get 4, you could pause, you could fill out the chart, then you can check back with me. Right? I got 11,303. Maybe do 5 on your own. Pause the video, try it with a calculator. Alright, so I'm down to 9,268. Looking at that, 0, 25. Let's do the same. No, let's not. Let's go 0, 1, 2, 3. This would be 5 here. Alright, then 0 was 25, so let's go by 2,000. So after 5 would be 10. After 5 more would be 20. So I'm thinking 25 is right here. 2,500 would be just above the 20,000, I mean. Then I need just above 16,800. Be about there. 3 would be 13,700. So that's just under 14,000. 11,300 would be 4. And 5 would be just here, about there. So you can see this exponential growth function is going to taper off. So that would be my graph. And then it says graph the function, estimate the car's value after 5 years. Here you go. You can write me a nice sentence and tell me after 5 years it's 9,268. Important thing is if you don't have a calculator, you're in a lot of trouble. You need to know how to use a calculator. It is a skill worth having. And the calculators are $8 to $10 at Target, right? I was just there. I know they have them. So get some. All right, be productive. Use your resources. Okay, this was a long notes video. The next 2 are shorter, around 14 minutes, 15 minutes, right? So you need to understand what you're graphing, how to get those values, and make sure you understand increase, decrease. This is depreciation, so you kind of knew what some of the expected values were. So make sure you're understanding. Ask questions. We're here to help. Have a great day. Thanks for listening.